Welcome to the Learning Pines YouTube. We hope this video helps.
You begin by verifying Fisch supports native threads and that the thread module is loaded. Once confirmed, pick the exact function you want to run concurrently and design a small, focused data object to pass in. Initialize any needed locks or channels now so you avoid race conditions later. Create the thread with the lightweight thread spawn call, provide arguments, and immediately check the returned thread handle. This first step gets the process running and prevents common initialization mistakes. Once the thread is running, set up your communication pattern, channels for messages or a thread-safe queue for bulk data. Make sure you only lock around critical sections to keep concurrency efficient. Excessive locking reduces throughput. Implement heartbeat checks or status flags so you can detect stalls, and use timeouts on blocking calls to avoid deadlock. If threads must coordinate, use condition variables or events. Otherwise, keep them as independent workers to improve scalability and recoverability. To finish, signal threads to stop using a shutdown flag or cancellation token, then join them to collect results and ensure orderly termination. Make sure you release all locks and close channels so resources are not leaked. Log final states and any errors for postmortem. If something goes wrong, reproduce the issue with a minimal input set, enable verbose logging, and check for common problems like uninitialized data, forgotten joins, or blocking I/O. That troubleshooting step quickly reveals the root cause.
Thanks for watching. Consider subscribing if we helped you.